of the things that we're going to look at today is graphing absolute value functions. If you wanted to graph this, y equals the absolute value of negative x plus 4, one of the things you could do is you could first graph what's inside. So what is inside is just the negative x plus 4. You know how to graph that. That's just y equals mx plus b. It would have a y-intercept of 4, a slope of negative 1, and it would keep on going down like this. That's negative x plus 4. Now, what does an absolute value do? It changes positive numbers to positive numbers. I don't know if I should use change because it kept it the same. But it changes the negative numbers to positive numbers. So if we did a table of values, notice that 4 would stay 4, 2 would stay 2, 0 would stay 0, but negative 2 would get changed to positive 2, and negative 4 would get changed to positive 4. And so what's happening is on this blue graph, notice all of these negative values are getting flipped up. So all that's happening we flipped the graph where the y values were negative over the x-axis. And so a very important point is the x-intercept, because that's where you're going to get the sharp part of your absolute value graph, and they call that very important point, almost very important point, they call it critical point, because it's very important, or critical. And we talk a lot about critical points in grade 12 in AP Calculus. So the graph changes direction at that point, and you get this V-shaped graph. And this strategy of graphing the inside and then flipping the negative part up is what we're going to use over and over for graphing things. Okay. Now, some things to be careful with, okay? Because this is what people are used to, right? You're used to making negative things positive. So the number one mistake that sometimes happens is you get something like this, and you're tempted to just make it x plus 4. That is not allowed, because absolute values say first you have to get a single number inside. Remember when we did that? It was at chapter 2. First you had to get a single number inside, then you could make it positive. And unfortunately, with negative x plus 4, you don't have a single number inside. You just have to leave it. So we will graph the inside and flip the negative part up, and that will get us our answer. Okay, so let's go to example 1. So we want to sketch the graph of the absolute value. So first, let's graph y equals 3x plus 6. I'm going to do it in blue. If you just have a pencil, maybe you do it with a dotted line. I'm going to do them both on the same graph. You might want to put them on separate graphs. So 3x plus 6, that would have a y-intercept of 6. A slope of 3, so I could go up 3 over 1, or I could go down 3 over 1, and down 3 over 1 again, down 3 over 1 again. There is y equals 3x plus 6. Very important to label that x-intercept. I can also label my y-intercept because they're going to ask for everything later. If I first graph that blue graph, then I'm going to graph it with the absolute values. And I'm going to do that in green. So I've got my original graph. The absolute value keeps positive things the same. So wherever my y values were positive, that's going to stay positive. But wherever my y values were negative, for example, at this point here, I have -3, -3 on my blue graph. I'm going to get on my green graph -3, +3. So notice the x value doesn't become positive. It's just your y values that become positive, and it would flip this part up over the x-axis. And that's the strategy for graphing absolute value graphs. So, identify intercepts. Well, the y-intercept is still 0, 6. The x-intercept was -2, 0. Domain was everything. And your range, now your y values are bigger than or equal to 0. So circle questions 4, 5a, 6a, no, all of 6, sorry. 7a, and 10a and b.